I'm going to show you guys how to make a half bridge. So you're going to need two identical MOSFETs or IGBTs, a heatsink for those, and I'm going to be powering mine from the wall, so I'm going to need a rectifier and a heatsink for that rectifier because it'll probably get hot. Then you need two identical capacitors or two identical capacitor banks. I'm going to make two capacitor banks like this. Need two power supplies for the gates of your MOSFET. These are 18-volt ones. You'll need your gate drivers, which consist of about 2,000 ohms of resistance for the input. So I have two 1 kilo ohm resistors. You got the actual chip, which I'm using HCPL 3120, and your gate resistor, which if you have chips this small, probably do like 10 ohms or something, but these are 2.2 ohms just because that's what I found. And you see, you want to wrap these wires up like this because it's just better. Here we have another power supply, 12 volts, and a fan to cool this down. And here's our basically signal generator. It decides the frequency and the power output of our half bridge. You can see it really looks really bad because I don't have any boards, so I just made it all free floating. So here's this circuit here. You can see the potentiometers, and they have these capacitors across them called decoupling capacitors. There's your timing capacitor and a soft start capacitor. There's your out 1 and out 2 that are 180 degrees apart. That controls your duty cycle. I think this is supposed to be for voltage reference, and that's your frequency. So I'll show you what this does. Here's a much nicer example of that SG3525 circuit. So you have this thing on the back, so I can choose timing capacitor, and it just looks a lot better. You can see the decoupling capacitors that are all 0.1 microfarads. So I have it connected to that 12-volt power supply, and you'll notice something. When I first turn it on, you notice the duty cycle increases slowly within the span of like 2 seconds. And that's what the soft start capacitor does. So I can adjust the duty cycle and the frequency. And that's basically what will control our MOSFETs. For this circuit, I would recommend putting a 10K potentiometer like there is here, so that you can adjust it so it's not 100% duty cycle, because then you might have some cross conduction, which is bad. So you can see I've connected these up. We got one out going to one of these transistors and the other out going to our gate drivers, and then the ground are connected to both the same. And then we just have to connect our 18-volt power supplies over here, negative and positive. And this is how you wire up your gate drivers. You got from out, one of these outs comes in, goes through this, there's an LED in there, negative. And then over here, positive, minus, and then gate resistor, You're going to want to use some sort of film resistor, because wire wounds have a lot more inductance, which is bad. Then it goes to your gate, and then your negative goes to your emitter. So I connected them up, and now you just take these and connect them to the gates. As you can see, everything is nice and unorganized. So I'm going to get these mounted up, everything mounted up. So I got the MOSFETs mounted up in this. And now we just connect up the capacitors, the rectifier, and the transistors like this. And then I'll hook up the gates as well. So you can see how this resembles that little circuit that I drew. But in this case, we're using 2 capacitor banks instead of just 2 capacitors. So this will just go to the wall. And now I just have to connect the gates and everything should be working. So this will be one output, and then the other output will be this wire. So I'll attach 2 leads, and that will go to our transformer. So I'm powering this thing with my little power supply. It's like 10 volts. And show you. So once I plug the SG3525 thing in, it should start working. Yep. And the thing with half bridges is it basically halves your input voltage. So we got 20 volts in, and there's only 10 volt peaks. And let's try to adjust the frequency. There we go. And the duty cycle. So if you input, mains voltage, that's a peak of 170. So you're only gonna get 85 volt peaks out of it. So then I need to connect some wires so I can actually power stuff with it. So I've attached some output wires. I just put a 10 ohm resistor. And we'll see what the output looks like now. It should look better than it does with no load. You can see we can adjust duty cycle. Very good. Here I have the half bridge powering this TV transformer. Here's a transformer that I made. I'm going to power it with this. Yeah, and I killed the MOSFET. I killed something. Here's another half bridge I built. You see much larger transistors, capacitors, heatsink, and here's your two outputs. And I just use those 118-volt power supplies. From here, this used to be a full bridge, because full bridges are better. See, it's much larger. We have a big fan, everything. And that's what that one good looking S3 3525 is from.